are calculating the value of each trig function, and it's so important that you get into the habit of not using your calculator because these are exact. That's why we have our trig ratio chart to help. We have our unit circle to help. And for this quiz, because a student asked me, what would you suggest as far as should I use my unit circle, should I not? And my answer was, I think you should try it without at first, but be honest with yourself because you're still learning, you're still memorizing, you're still getting comfortable with it. So if you try it without and then you go as far as you can go, then pull it out because it's a resource for you. So then you can use your unit circle and your ratio chart, okay? Take the quiz as an opportunity to really assess where you're at right now with this content. And, you know, be honest with yourself. It's you, not me. I'm going to look at your work. I'm going to see that you attempted, and that's what matters to me for the quiz, okay? All right, so number one, we are looking for the tangent of 5 pi over 6. Okay, thinking about where that is on our unit circle in relation to the x and y axes, pardon me, it's a positive radian measure, so we would rotate counterclockwise. 5 pi over 6 doesn't take us all the way to pi, so we know that we're in the second quadrant. Okay, here's my little triangle. Again, you don't have to draw this. If you don't need the visual, that is okay. But I can tell you that our reference angle is going to be pi over 6. So that means we're using the coordinate of rad 3 over 2 comma 1/2. And we're in that second quadrant, so the x coordinate is negative. Okay, tangent is sine over cosine. If you aren't 100% comfortable yet with knowing your tangents right off the bat, you can always take the sine and divide it by the cosine value. So let's do that right now, yeah? We're going to take 1/2 and divide it by negative rad 3 over 2. In dividing fractions, we keep the first fraction and we multiply by the reciprocal of the second. The 2's will cancel out, and we're left with negative 1 over rad 3, but we have to rationalize. So I'm going to multiply by rad 3 over rad 3. Thus, the tangent of 5 pi over 6 is a negative rad 3 over 3. Now, a little friendly tip, I would say, if you are trying to memorize your tangents, tangent of 45 is always 1 because it's an isosceles triangle. The legs are the same. We just have to think about, is it positive or negative depending on where we are in the quadrants. The tricky part is pi over 6 and pi over 3, our 30 and our 60 degrees, right? Well, if I'm looking for the tangent of pi over 6, which is 30 degrees, in relation to the tangent of pi over 3, which is 60 degrees. 30 degrees is smaller than 60. So it makes sense that the tangent of 30 would be smaller than the tangent of 60. If you're struggling with trying to remember the tangent of 30 and the tangent of 60, just think about which one is smaller. That must associate to the smaller ratio. Okay, now if that doesn't help, not offended, but hopefully that helps a little bit in trying to memorize our tangents, because those are a little bit tricky. All right, number 2. Number 2 is cosecant. Now, cosecant is the reciprocal of sine, okay? We're looking for negative 3 pi over 2. Since it's negative, we're going to rotate clockwise. And I see that my denominator is 2. Normally we have a denominator of 6, 4, or 3. If we see that denominator of 2, we should be thinking that we're going to land on the axes. Why? Because 90 degrees is pi over 2. So drawing my rotation, starting on that positive x-axis, I'm going to go down pi over 2, 2 pi over 2, boom, 3 pi over 2. We are on the positive y-axis at the coordinate 0, 1. And we need the cosecant. So remembering that these coordinates are written as cosine, comma, sine, alphabetical, yeah, C before S, then we know that the sine of negative 3 pi over 2 is 1. What's its reciprocal? Yeah, it's just 1. So the cosecant of negative 3 pi over 2 is just 1. How are we doing so far? Okay. Okay. All right, let's take a look at number 3. Oh, yeah, cotangent. All right, cotangent is the reciprocal of tangent, but we have this 16 pi radian measure. Holy moly. All right, there's 2 ways to go about this. If you're a visual person, you may want to draw the x and y axes. All right, and think about how many revolutions is within 16 pi. Well, we know that 1 revolution is equivalent to 2 pi, right? Okay, my little thought bubble. There we go. So if I were to draw this, every time I go around in a circle, I'm traveling 2 pi radians. Okay, here we go. We've got 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi. Holy heck! That's a lot of circles. And it kind of looks like a hot mess. So here's another option. If you don't want to draw a bunch of circles around your origin to figure out where you land, you could simply take the radian measure that you're given, divide by a full revolution. How many 2 pi's can I take from 16 pi? 8, exactly. Aha. So if I take 16 pi and I subtract 8 revolutions, ultimately what I'm left with is 16 pi minus 16 pi, which is what? Yeah, very good. It's 0. There isn't anything left over, so right away I know that I'm going to be on the positive x-axis. Okay, sometimes we find this to be a little bit smoother than drawing circle after circle after circle. So here we are at the coordinate 1, 0. Cotangent is the reciprocal of tangent, so therefore it is cosine over sine. It is x over y. What is this? Undefined. Very good. If you have 0 in the denominator, ladies and gentlemen, you cannot divide by 0. So the cotangent of 16 pi is undefined. Awkward Zoom silence, waiting for questions. Okay, let's move on. Moving on to number 4, like I mentioned, I'm going to do some with you, and then I'll let you guys try some on your own. So I'll do a couple more. The sine of negative 11 pi over 6. Okay, few things I'm thinking immediately. First, it's negative, so we're going to rotate in the clockwise direction. Second thing, if I have a full revolution, we know it's 2 pi. But let's make it equivalent to a denominator of 6. Yeah, why? Because we're given a denominator of 6. So if I travel around, 2 pi radians, that's equivalent to 12 pi over 6. So the given radian measure is not a full revolution, but it's pretty darn close. If we rotate around the origin, negative 11 pi over 6, we should end up in the first quadrant. And our reference angle is just pi over 6. Even though we had a negative radian measure, that just told us to rotate clockwise. The reference angles are always positive. The reference angle represents the distance in between that terminal side and the x-axis. So they will never be negative. Okay, super important, you guys. So since it's pi over 6, we're going to use the coordinate of rad 3 over 2, comma 1/2. We are in the first quadrant, so every trig function is positive. Sine is the y value, so we can say that the sine of negative 11 pi over 6 is 1/2. Oh, it's a lot to think about. Good stuff, though. All right, last one, and then you guys get to try some on your own. We've got the cosine of 19 pi over 3. Now, our denominator is 3. So a full revolution with a denominator of 3 would be 6 pi over 3. Right away, I see that I have more than one revolution. How many 6 pi over 3s can you take from 19 pi over 3? Yeah, 3. 3. Thanks, you guys. Nice job. So if we have 19 pi over 3, and we subtract 3 6 pi over 3s, what we're doing is taking away 3 revolutions. We're taking away 18 pi over 3 so that we can see what we're dealing with. And in this case, it's just pi over 3. Now, the given radian measure is positive, so I'm going to rotate counterclockwise, and I end up in the first quadrant. Okay, our reference angle is pi over 3, so the coordinate that we're going to use is 1/2 comma rad 3 over 2. We're looking for the cosine. Cosine is the x value on our unit circle, so the cosine of 19 pi over 3 is 1/2. Sweet. All right, so we have 6, 7, and 8, and 9. Your math teachers can't count. That should be an 8. All right, please try 6, 7, 8, and 9 on your own, and then we'll come back together as a group and see how we did. Long, yeah, but let's check and see how we're doing. What? Is that even English? All right, here we go. The secant of negative 9 pi over 4. The secant is the reciprocal of cosine. It is a negative radian measure. Okay, so we're going to rotate clockwise. Now, one full revolution, if I change this to have a denominator of 4 so that I can make that comparison, would be 8 pi over 4. Okay, so taking that into account, if I have 9 pi over 4, negative number, don't think about it for a minute. Yeah, if we have 9 pi over 4 minus 1 full revolution, that means that we're going to rotate negative pi over 4 radians. That lands us in the fourth quadrant. In the fourth quadrant, we have, let me draw it real quick. There you go. In the fourth quadrant, tangent and cotangent, cosine and secant are positive. So if we are here, our reference angle is pi over 4. That means we're dealing with the coordinate of rad 2 over 2, comma rad 2 over 2. In the fourth quadrant, your y values are negative. So taking the cosine of rad 2 over 2, flipping it upside down, we should end up with a positive rad 2. All right, let's take a look at number 7, and then I'll take questions if you have them. 15 pi over 4. Woo! Again, we know that full revolution is equivalent. I don't know what is happening to my pen. Uh-oh. Houston, we have a problem. Okay, it's just really slow. There we go. So 1 full revolution is equivalent to 8 pi over 4. If I have 15 pi over 4 and I take 1 revolution away, then that leaves us with 7 pi over 4. If we were to rotate 7 pi over 4 radians, we end up again in the fourth quadrant. So I'm going to draw my little triangle. Again, you don't have to. This leaves us with a reference angle of pi over 4. All right, the coordinate, just like we saw with the previous example, that we're going to use is rad 2 over 2, comma, negative rad 2 over 2. Now, since these are the same, this is so nice for tangent, the denominator is 4. We're dealing with a 45-degree reference angle, or pi over 4. In the fourth quadrant, that means that tangent is negative 1. All right, questions so far on 6 or 7? 6, no? Okay. Number 6 was rad 2, I believe. Yeah. Let me see. Yep, it was. All right, you guys, 2 more. The sine of negative 5 pi over 3. We are rotating clockwise. So if we rotate clockwise 5 pi over 3 radians, we're going to end up in the first quadrant. Our reference angle is going to be pi over 3. First quadrant, every trig function is positive. The coordinate that we're going to use is 1/2, comma, rad 3 over 2. So looking at our y value, the sine of negative 5 pi over 3 is rad 3 over 2.
Ms. Patterson, did we get negative 1 for number 7?
Yes. You're welcome. All right, ladies and gents, grand finale. Here we go. Cosecant. Cosecant is the reciprocal of sine. Denominator is 6, and I can tell already that we're beyond 1 revolution, right? So just to make that comparison, 12 pi over 6 is equivalent to 2 pi. So if I have, again, ignoring the negative for right now, 17 pi over 6, and I take away 1 full revolution, we end up with 5 pi over 6. So we're really rotating negative 5 pi over 6 radians. This isn't a full half revolution. So if we rotate clockwise, hopefully you ended up in the third quadrant with me. Our reference angle should be pi over 6. And the coordinate that we're using is going to be rad 3 over 2, comma, 1/2. But, hello, third quadrant, everything's negative. So the cosecant of negative 17 pi over 6 should be negative 1/2 flipped over. Taking the reciprocal, we get negative 2.